All right, so in this video, it asks us to find the values of theta where the polar graph, which is r, is 1 minus sine of theta, on the interval from 0 to 2 pi has horizontal and vertical tangent lines. All right, so first thing I notice is this is not given to us on the type of graph like this polar coordinate plane. But I can still graph polars on what looks like an xy plane. So I've got to recognize that this is still theta as 0. This would represent about theta of is equal to pi over 6, and that would be the radius. This theta is still pi over 2. The radius would be 0. This could be, if I go right down the middle, 45 from that. So that'd be like, what's that? 1, 2, 3 pi over 4. So the theta is still 3 pi over 4, and that would be the radius. Theta is pi. The radius would be, looks like 1. So I still have to be able to recognize that all the points on there are still thetas and r's. So this says where, or for what thetas is the slope of the tangent line vertical and horizontal. So first of all, tangent line here, horizontal. Same tangent line for a different theta. One of the thetas is here. One of the thetas is here. The other theta would be there. So that theta looks like what? 1, 2, 3 pi over 2. The other one's not so easy to tell. And then my vertical tangent lines happen here and here. So what is the theta that gives me those numbers? So it's kind of tricky. It takes a little time for it to fully sink in. I don't know if it's sunk in for me yet. So I need to find those thetas when all this stuff is, the slope is 0. Okay, so I got to think. I need to find I have a horizontal slope when dx dt is equal to, what am I doing? This is not even the right problem. When dy dx is 0. dy dx is equal to 0. I have a horizontal tangent line, right? Horizontal tangent. So the horizontal tangent line is when the slope is 0. And then I get vertical tangent lines when dy over dx is undefined, right? So I have horizontal tangent lines when the derivative is 0. So when the top is 0, but the bottom can't be 0. And I find the top, that's just y prime, right? I got to find out when is y prime of theta equal to 0. But x can't be 0, x prime can't be 0 also. Because if I'm dividing by 0, I can't have them both be 0 at the same time. That just can't happen. But if the top is not 0, but the bottom is 0, that's when I have an undefined slope. But they can't be 0 simultaneously. All right, so I've got to find out, well, where is y prime equal to 0? First, I need to know that y is equal to r sine theta. So if r is equal to y, or r sine theta, then I know r is equal to something. So my r is 1 minus sine theta times sine theta. So there's my y. Now I got to find y prime, but I think it's going to be easier if I distributed the y. I could do product rule right here. But to find y prime, I think it might be easier to find out what y is if I distribute. So that would be what, I'll get the same thing. So what, sine theta minus sine squared theta. So y prime is equal to, the derivative of sine is cosine theta minus 2 sine theta times, the derivative of sine would be cosine. There's a little chain rule in there. I would have gotten the same thing if I did the product rule, which I'll probably do that with the other one. I'm not sure. All right, so there's y prime. I'm trying to find out, remember, where y prime is equal to 0. So I got to solve this for 0. So what I might do here is factor out a cosine. So cosine of theta is equal to 1 minus 2 sine theta. Where is that 0? Okay, got to find out where is cosine equal to 0. Okay, cosine is equal to 0 when theta is equal to pi over 2. And when theta is equal to 3 pi over 2. All right, if I'm thinking about that, okay, one of them makes sense. So right here, this, I'm going to draw this. This right here, that is reference angle pi over 2. Is there a tangent line that is horizontal there? No, but we'll talk about why in a second. If theta is 3 pi over 2, is there a horizontal tangent line there? Yes. Okay, so we're going to talk about y in a second. So I also could have a horizontal tangent line for these numbers, right? For those theta numbers. So I got to find out what is the theta that would have radius, boom, right there. So what's that point? So I find that one by setting this equal to 0. That factor would be what? 1 is equal to 2 sine theta. So where is sine theta equal to a half? When theta is equal to pi over 6 and 5 pi over 6. And I think my pen is running out. All right, that makes sense. There's pi over 6. There's 5 pi over 6. So it's looking like this one for sure. No, not that one. This one for sure, this one, and this one. But something's happening when when theta is pi over 2. All right, so let's shift gears here. And let's find out where is there a vertical tangent line. So looking at the graph, it looks like at that point right here, right? I just erased it. This point right there. So I got to find the theta where that happens. Okay, so dy dx is undefined. If the denominator is 0, the denominator is the dx part. So where x prime of theta is equal to 0, but y prime can't be simultaneously 0. All right, so let's see. So x is equal to r cosine theta. X is equal to, plug in r, so I've got 1 minus sine theta times cosine theta. So x of theta is equal to, okay, I'm going to multiply this out. Actually, let's see. Let's find the derivative here. Let's do the product rule. The derivative of the first would be negative cosine theta times the second plus the first thing times the derivative of the second, which is negative sine, right? Times negative sine theta. Okay, if I multiply that out, this is x prime. I get negative cosine squared theta plus, what would that be? Oh, minus, I guess. Minus sine theta plus sine squared theta. So from here, I'm going to use a trig identity. I'm just going to tell you. Sine squared theta plus cosine squared theta is equal to 1. So I'm going to do a little trick, and I'm going to replace negative cosine squared with sine squared minus 1. Because if I solved this, if I subtracted cosine squared from both sides, subtracted 1 from both sides, I would get that. So this is equal to sine squared theta minus 1 plus sine squared theta minus sine theta. So the derivative is equal to 2 sine squared theta. Where did this minus 1 come from? Oh, minus 1, duh. Okay. Minus sine theta minus 1. All right, I'm also going to tell you can just factor this into something ridiculous. So the first two terms, I'm going to treat this like an x squared, but it's sine. And this would be my x, but it's sine. So I'm basically factoring 2x squared minus x minus 1. But x is sine squared. So this is 2 sine theta plus 1, sine theta minus 1. So to find out where those are equal to 0, theta is equal to, gotta find out which, each one is equal to 0, right? So theta is equal to 0 when, this is equal to 0 when theta is equal to 7 pi over 6 and 11 pi over 6. Just kind of figuring out where is sine equal to negative 1/2 and then where is sine equal to 1. We get pi over 2. All right, so at 7 pi over 6, that's that angle. So at that angle, I have a tangent line. At 11 pi over 6, there's the angle. And at pi over 2, that's where we had like both 0. So if you look at it, there's some kind of weird happening there. There's a cusp. So the derivative doesn't exist there. It's a sharp corner. So the derivative of y and derivative of x are both 0. The derivative just doesn't exist, sharp corner. So that's like an extra. So there are the thetas when we get vertical tangent lines. All right, complicated question. Might have to rewatch this one a couple times for it to really sink in. A lot of stuff going on there. So thanks for watching. Hopefully this helped. And if you have any questions, next time I see you in class, make sure you ask. Bye.